students, welcome back. So the last stream that we covered in our previous class, it was buffer input output stream. Hopefully you people are following these lectures. I really do not see many questions posted on the forum. I would strongly recommend that if you have any confusion, please update your questions on this forum. I will answer these questions on Friday, June 12, 5 to 7 p.m. So the last thing that we covered, it was buffered input output stream, which is one type of filtered output stream. We discussed in the previous video that these filtered output streams or input streams, they are actually kind of wrapper on underlying streams. Like we can open buffered output stream on a file output stream, and when you do that, you will actually improve performance of writing in the file. When you directly write by using file output stream, for every character you perform a write operation on the disk, but when you do it through buffered output stream, the write operation will be inside local buffer, which means that overall performance will improve, because for each character you really do not need to refer to the file, rather you will be writing in the local buffer. That's always much faster than writing to a disk. Another type of filtered stream is this pushback input stream and pushback output stream. These two streams have got fantastic capability, which is to unread. I mean, so far we have been seeing that we can read, but it is equally important to unread some of the contents which you might think are not required at the moment, because if you see in all these reading and writing process, we have seen that there is a kind of cursor, there is a kind of pointer that moves forward as you read next character. But say for example, you read next character and you realize that no, you do not need this character, and you want to keep it back to the stream, you want to unread it, then this pushback stream provides you this facility. It has got again that filtered output stream constructor, in which you have got push input stream, which will be created on the top of another stream, and pushback input stream can be created on top of another stream by mentioning how many bytes to be read, right? And these are the methods due to which we call this is one of the great streams. Unread, you can unread 1 byte at a time, you can unread whole buffer at a time, or you can read this buffer starting from offset up to number of bits, right? Let's see an example of this pushback stream, and then you will get a very good idea about this stream. See here, I mean, I have this input, and what I want against this input, I want to display if A equal 4, A, maybe for this I can have this sign, right? 0, right? So for this output I want to produce this output, right? Now you can understand that when you read this character, you are not sure if the next character is this space or if next character is equal to sign. Now if the next character is equal to sign, then you can produce this combination. But if, say for example, next character is not equal to sign, which means that you should keep even this character back into the stream so that it can be read next time, because you would like in that case that if this is single equal to, you want to produce this combination rather than this combination. So in this case, if you read this and you encounter next character this, produce this combination. But if you read this and you encounter a space, it means that you have to keep this back into the stream. So that is where this pushback input stream will assist you. Let's see how this is done. So we have got this string, and our target is to produce corresponding this string. So we first get bytes, as we did in the previous videos. So byte array input stream, we are opening byte array input stream on the buffer, right? we read one character at a time. We say push back input stream. You can see we are again using try with resources, which means that connection to pushback input stream will be automatically closed when this program ends, right? And you can see because this is one of the filtered input streams, so you are opening pushback input stream onto another stream, and in this case this another stream is byte input stream. It can even be file input stream or any other type of input stream, right? So we read one character at a time. We say c equal to if dot read. If it is not equal to -1, I mean if it is not end of the stream, then we switch on character C. We say case C, and then we read one more character, and we say if it is equal to this one, it means that we have encountered this combination, so we actually print dot equal dot, I mean this combination, right? Else we say system.out.println, we want to print this one, and the problem is we have read this next character, which we want to keep back to the stream. So that is the reason why I say if dot unread C. It means that this next character which we have read, which is actually space, if we are here, then we keep this character back into the stream and then break, and for default we just print all these characters, right? So when you run this simple program, you will see that the output will be as we desire. So if a dot equal to 4, then a less than equal a equal to 0. So you can see here, in place of this combination we produce this combination, and in place of this combination we have produced this combination. But the important thing is, see how we unread. We unread this space because we would like that it should be read next time, so that default is executed, and when default is executed, then it will just display this space sign. If we do not unread, then obviously this space will be eliminated. For example, if I just make this commented, you will see that space has been eliminated. Now this does look very ugly. There was a space after this equal to sign, but because that space was consumed inside this nested read, that is the reason why we lost it. So we said no, we do not want to lose any character, we want to keep it back to the stream. That is the reason why we need to unread it. Unread it means the latest bit that you have read, it should go back to the stream, right? So you can see here, that is the reason why now your output is as per your expectation. I mean, when you will be working in practical life, you will see scenarios. This is a very simple scenario, but you will see a lot of practical scenarios where you will be needing to unread the latest read character. Right, so that is pushback input stream. Then we also have sequence input stream. The sequence input stream is nothing, just combining multiple streams. You can see here, if you want to open sequence input stream on 2 file input stream, there can be first file input stream, there can be second file input stream. Your first file input stream can be opened on, say for example, file 1, this can be opened on file 2. So when you read by using sequence input stream, it will first exhaust first stream, and then it will exhaust second stream. It means that you can actually combine multiple streams to be read by using sequence input stream. It's a kind of a lazy approach. If you want to combine multiple streams at a time, you can do the sequence input stream. Enumeration is one of the very good structure in which you can put even more than 2 streams. If you have to combine, say for example 100 streams, you can create an enumerator, and all those streams can go into enumerator, and then you can refer all those streams one by one from the enumerator. Right, we haven't covered java.util. I strongly recommend you guys to study java.util, because there are many utility classes that you will be very exciting to work with. As I told you earlier, because I have taught you basic Java, you know how classes work, how methods work, how multi-threading works, how exception handling works. So these basic skeletons are covered, then you can do anything on your own. Right. Okay, then print stream. Remember, this stream you have been using since your childhood, because system.out, I mean we have been using system.out for ages. You know that in the very first class we wrote system.out. Now remember, system is a class in java.lang. So maybe in java.lang it is declared like this, class system, right? So this class is declared in java.lang, and inside that it has got a static member variable, and that is the print stream, and its name is out, right? Now remember, because this is static, so we can refer it with the class name, but this out is actually a reference of print stream, right? Now this print stream, the way file output stream is associated with file, the way byte array output stream is associated with the array, the way socket output stream is associated with the socket, your print stream is associated with console. It means that anything that you display by using print stream, it actually goes to the monitor, to the console, right? But you can open print stream on any other output stream, which means that you can open print stream on file output stream, you can open print stream on byte array output stream. I mean, because the constructor accepts output stream reference, it means it can accept anything, right? And you can see here, it throws the other constructor which is having output stream and then auto flashing on, it actually throws unsupported encoding exception. Here is another set of constructors. Your print stream can also directly write to the file, rather than opening a stream on file output stream. You can also open a stream directly to the file output stream. In that case, whatever you write, it will be written to the file output stream, right? You can also specify character set like Unicode, like ASCII, whatever you say. It is also important when you want to write Unicode, this print stream can help you, right? So there are many methods in the print stream that we have already been using, like println, like print. But one of the methods that they added very recently, it is printf. I mean, if you are coming from C++ background, you know how important is printf. It actually prints your string in a very formatted fashion, right? Let us see one of the example of this print stream class. Print demo. You can see here, I mean system.out. This out is object of print stream. Inside this, you've got a println. Here are some numeric values in different formats. For example, here we are using printf. Now, when you are using printf, you can use C++ like formats inside Java, like %d, opening bracket d, which means a negative number, percent and plus d, it means it will display plus sign with the number, %05d, which means it will display 5 zeros before the number. So you can see here we have got these number 3, -3, 3 and 3. In this case, it will actually display 3, and then it will display minus. I mean, usually in accounting, this bracket and closing bracket and number inside these two will actually be represented as a negative number. So we replace this negative number by this format. You can do that. Then we have plus d, which means that if you directly print 3, it will be printed only 3, but if you print % plus d, it will be written like this. And then if you say I need 5 zeros before 3, so 4 zeros before 3, so you can do this. So this formatted string will be like this, right? Similarly, you can also do floating point formatting. You say %f, yes, it will be displayed. This %f will be replaced by this number at the runtime. You say rather than decimal point, along the decimal point, I also want a comma. You know that in accounting, comma is used after every 3 numbers starting from the right. So this will actually display things like this, right? So this is kind of 1 million, 1.23 million. So yes, this comma can also be added. If you add, it is more important when you are doing in accounting thing. There are multiple other formats. I mean, whatever you need. This one is actually saying that I need only 2 numbers after decimal point. So all these formats, when you run it, you will see the output. So you can see the default, this one you can see 3 plus 3 and this, then floating point, then this is for putting comma, displaying more floating point. So you can see all these formats are available with print stream, and this is thanks to this printf method of print stream. But more importantly, you need to understand that this print stream is the one that we have been using from beginning. I mean, here I do not import anything because I don't need to, because system class is in java.lang, and I'm using this out from print stream. Out is a reference of print stream, and obviously because inside system class they are already importing print stream, so I do not need to import it here, right? But this print stream, like file output stream, this print stream is associated with the console. So anything that you display, it will go to the console, right? So you got a very important answer today. Right from the first day, we have been using system.out.println. So now you know what is system, you know what is out, and you know what is println, right? So that was print stream. The next set of a stream is data output stream and data input stream. I mean, again, this is just for the programmer facility. If you do not have data output stream or data input stream, you can still live happily, but this is just to facilitate you. If you want to write Java's basic primitives like writing integer, writing double, writing boolean, then you will have this data output stream and data input stream. Data output stream and data input stream will be opened on an underlying stream. I mean, if you are opening it on file output stream, then you can write Java primitive to a file. But if you are writing it to, say for example, console, which means that data output stream will write primitive to the console. If you are opening data output stream to a socket, it means that data will be written to a socket, right? So again, the point is your data output stream will be requiring an underlying stream, and you can write basic Java primitives to the underlying stream. We will see one example. You can see here it has got these three important methods. One is write double, which will write double value of Java, write boolean, write integer. The corresponding input stream for data output stream is the data input stream, which actually can read double, it can read boolean, and it can read integer, right? The beauty of this stream is it will maintain the Java primitive type. If you read and write directly by using file input stream, you will actually be reading in terms of a string. You will be reading text. You will lose the format type, right? But if you are using data input stream and data output stream, Java will regard the data type that you are writing to the file and which you will be reading in the future, right? Again, let's see one example. I have got this data IO demo. In this program, what I'm doing, I'm again using try with resource. So I say data output stream equal to new data output stream, and this data output stream is being created on file output stream, and I'm passing this link to the file, that is test.txt, right? It is here, the folder is being created here, right? So present, you can see inside this is Spring 2020 file, there is nothing, but I will write these things. So you can see data output stream dot write, I'm writing this number, data output stream dot write, I'm writing this number, and data output stream dot write boolean, I'm writing this boolean value. Now you know that I'm using data output stream to write all these three, but because data output stream is associated with file output stream, which means that all these numbers will actually be written to file output stream, which is connected to test.txt. It means that eventually this data will go to test.txt. Obviously, this throws a file not found exception, so we need to catch it. I'm returning from here if there is an exception. If there is an exception, which means that we have not been able to write, so we should not read. But if exception is not thrown, then I'm coming here. I say data input stream, file input stream. I'm associating my file input stream on the same test file that I have just written. And then I see double D, data in dot read double dot read int and dot read boolean, and then I'm just displaying these three values, right? D, I, and B. So you can see here I wrote these three values to the file, and here I can read them again from the stream. Remember, if you use direct file input stream, you will not have this facility. If you use direct file input stream, you can read one character at a time, but you will not be able to maintain the data type of the data that you wrote to the file, because when it goes to the file, it automatically becomes text. But your data input stream will actually, it's very smart, it knows that where double starts and where double ends. It knows where integer starts, where integer ends, and it knows how Boolean value looks like. Right, so it's very handy to have this data input stream and data output stream for writing Java primitives. Right, again, you will have a lot of practical scenarios where you will be needing this facility in your program. So after data input output stream, you have got one last thing before we move to the character oriented stream. So it is random access file. Random access file is same as file. We have been using file for quite some time. You can open random access file to a file. It might throw again file not found exception. The only difference in random access file and the traditional file is, in the random access file you have got the seek method, so you can specify any position, so the next read will take place from this new position. This is something that you do not have in ordinary file, but random access file have got this facility. Right, we'll be using random access file in future programs, so you need to understand that Java also provides this type of facility. Okay, so that marks end to all these byte oriented streams. I end this video here, and when I come back I will be discussing character oriented streams. That should be last video in the series of Java IO streams. Thank you very much.